Question 21. The velocity v of a particle in a time t is given by the equation v equals 10 plus 2t squared. Find the instantaneous acceleration after 5 seconds. So think about it. So solve it. So guys, welcome to Learn with Israel YouTube channel. In this video, we'll be treating episode 2, which will be from question 21 to 40. And in the previous episode, which is episode 1, we've done question 1 to 20. If you haven't watched the video, go and watch it out now. So in this video, we'll be treating question 21 to 40 on episode 2, which is on JAMB. This is likely question. And if you are interested in JAMB tutorial, you can start this number right here to join the group. So guys, let's go back to the question. So we have to find the instantaneous acceleration after 5 seconds. The velocity v of a particle in a time t is given by the equation v. So v equals 10 plus 2t squared. Find the instantaneous acceleration after 5 seconds. So guys, let's solve. Our v equals 10 plus 2t squared. So we have to find our acceleration. And the formula for acceleration is change in velocity over change in time. So this dv represents change in velocity, and this dt represents change in time. So our change in velocity is 10 plus 2t squared. So our acceleration equals over our dt. So let's cross multiply. So if we cross multiply, we are left with a into t, change in time. A into t equals 10. 10 is equals to 0 in derivation. 10 is equal to 0. Why is it equal to 0? Because 10 is constant. It's constant in the question. So 10 equals to 0. So our 10 is 0 plus 2t squared. 2 square is 4. So we are now left with 4t. 4t. I hope you understand that now. 2 square is 4. Multiply by this t, it will give us 4t. So our a t equals 0 plus 4t is also 4t. So what's t? Our t is time. It says find the instantaneous acceleration after 5 seconds. So let's change our value. Let's input our value. The value for t is 5. So our a equals 4 into 5. So let's multiply. 4 multiplied by 5 will give us 20. And the unit for acceleration is meter per second square. Don't forget, the unit for acceleration is meter per second square. So let's check our option. Yeah, you can find it in option B, 20 meter per second square. So let's move to the next question. Question 22. A motorcyclist traveling at 30 meters per second starts to apply his brakes when he is 50 meters from the traffic light that had just turned red. If he reached the traffic light, his deceleration is towards deceleration. Deceleration is going back. Why? Acceleration is moving forward. Deceleration is going back. For acceleration, you use plus. Why? For deceleration, you use minus. So the formula we'll be using. So before that, our velocity is represented as 30 meters per second. So our v, which is our given, our velocity 30 meters per second. And he said to apply his brakes when he's 50 meters. So that's our distance. Our distance is 50 meters. So what other thing do we have? We don't have any other thing. So let's solve. Our acceleration is unknown. So we have to look for our acceleration. So we'll be using v squared equals u squared minus 2as. Why are we using minus? We should be using plus, but why are we using minus? Because we have to solve for the deceleration. I explained that for deceleration is minus and for acceleration it is plus. So it's very important to note the question and to study it before answering it. So our v is 30 square equals our u is 0 square minus our, you know why our initial velocity is 0? Because it says a motorcycle traveling at 30 starting from rest, it starts. So our initial velocity is 0, while our final velocity is 30, it starts. Why? We have minus 2 multiplied by, what's our acceleration? Our acceleration is unknown, multiplied by our meter, and our meter is 50. Our meter is what? 50. So 30 square is 900. You can check your calculator. 30 multiplied by 30 is 900 equals 0 square is 0. So 0 minus 2 multiplied by 50a. Multiplied by 50a. So what is the next thing to do? 900 equals 0 minus 100a. 0 minus 100a. So we are now left with 900 equals minus 100a, because 0 minus 100 is minus 100. So don't forget to put this sign here. So let's divide by 100 to get our answer acceleration. To make our acceleration the subject of the formula. So let's divide. 100 divided by 900 is 9. And 100 divided by minus 100. So we are now left with 200 divided by minus 100. We are left with a, which is the acceleration. So our acceleration is minus 9 meter per second square, because acceleration is measured in meter per second square. And don't forget to put this sign, because minus 100 divided by 900 will be left with minus 9 meter per second square. So let's check our option. Yeah, we can find out in option B, minus 9 meter per second square. And if you don't understand any of this question, make sure you rewatch it and make sure you understand it. So guys, let's move to the next one. Question 23. A car accelerates uniformly from rest at 4 meters per second square. How far will it travel in the 5th complete second? In what? In the 5th complete second. So if you check the question well, we have 2 seconds. We are having 2 time, and I will explain how. So let's write out our givens. Our acceleration is 4 meters per second square. What other thing do we have? Our initial velocity is 0. Why is it 0? Because it is starting from rest. And we also have our time. We have 2 time. The first one is 5 seconds and the second one is 4 seconds. How? The question says, how far will it travel in the 5th complete seconds? In the 5th complete seconds. So when solving this kind of question, you need to calculate for the 5th complete seconds and the one before the 5th complete seconds, which is the 4th second. That is how we can know the exact one for 5th second. We need to calculate for both 4th and 5th. So that's why we are having 2 time here, which is 5th and 4th second. So our formula will be different. And what are we looking for? We are looking for the distance, which is s. It says how far will it travel in the 5th complete second. Our distance, the formula we'll be using is half at square minus half at square. The reason is because our time, we have 2 time, which is the 5th and the 4th. So we need to calculate for 5th and 4th and now subtract it so we can get the distance. In this kind of question, when solving this kind of question, use this formula. Assuming we have 1 time, which is assuming we are solving for 1 time, assuming we are solving for 1 time, we would have gone for only this. But since we are having 2 time in the question, we'll be solving it like this. So our distance equals half multiply by our a, which is acceleration, and our acceleration is 4, multiply by time. Our time, let's solve for our first time, which is 5. Our first time is 5 seconds. So let's square it. Minus half multiply by our acceleration is 4, multiply by our time, which is 4 square. We can't use 5 because we are solving for the second time, which is 4. So let's solve our, so 1 over 2, 2 cancel 4, so we are left with 2. So we are now left with 2 multiplied by 5 square is 25, minus 2 cancel 4, we are left with 2. So 2 multiplied by 4 square. What's 4 square? 4 square is 16. 16. So our distance equals 2 multiplied by 25 is 50. And 2 multiplied by 16 is 32. So let's subtract. So now let's subtract from for the 5th seconds minus the 4th seconds, and so we can derive our distance. So 50 minus 32 is 18. We can't leave it like that. We need to add the unit, and the unit for distance is meter. Distance is measured in meter. So the correct answer is 18 meter. So let's check our option. Yeah, we can find that in option A. 18 meter is the correct answer. So let's move to the next question. Question 24. A motor vehicle is brought to rest. Is brought to what? Is brought to rest. Note that. From a speed of 15 meters per second. So this is our final velocity, which is v, and this is our initial velocity, which is at rest, which is u. And our initial velocity is always 0 if it is starting from rest. So our time is 20 seconds. So let's write out our givens. Our u is 0 meter per second, and our v, which is final velocity, is 15 meter per second, and our t, which is time, is 20 seconds. 20 seconds. So how do we solve? The formula we'll be using for, it says calculate the retardation. The formula we'll be using is acceleration equals v minus u over t. When calculating for retardation, this is the formula you are going to use. Calculating for retardation also means we are looking for our acceleration, and to get the acceleration you need to minus the final velocity from the initial velocity and divide it by your time. So our acceleration equals, our final velocity is 15 minus our initial velocity is 0 divided by our time, which is 20 seconds. So our A equals 15 minus 0 is 15, and we are now left with 20. So 15 divided by 20 is, so check your calculator, 15 divided by 20 is 0.75. Can't leave it like that. I hope you know. Acceleration is measured in what? It's measured in, meter per second square. It's measured in meter per second square. So our answer is 0.75 meter per second square. So let's check the option. You can find it in option C. 0.75 meter per second square is the correct answer. So guys, let's move to the next one. Question 25. Capacitors are used in the induction coil to dash: A. Control circuit, B. Dissipate energy, C. Prevent electric spark, D. Prevent distortion. So capacitors are being used in the transformer in order to prevent electric sparks. It is being used in order to prevent electric spark. So option C is the correct answer. Question 26. The uses of lenses is not applicable in the A. Projector, B. Human eye, C. Periscope, D. Telescope. So let's start from projector. The uses of lenses is applicable to projector and in the convex lenses. Convex lenses for projector. For human eye, it is also convex lenses. The use of lens, it is applicable for the human eye. And for periscope, no. The use of lenses is not applicable in the periscope. Periscope is used to focus and observe image. Periscope is used to focus or transmit images. It helps in transmitting image. And for telescope is also the uses of lenses is also applicable to telescope, and it is in convex lens. Convex lens times 2. The telescope needs convex 2 times convex lens of the human eye or the projector and the human eye we use maybe one, but the one for telescope we have to double, because telescope is used for viewing stars, is used for viewing far images like star, so it has to double. Question 27. The pair of physical quantities that are scalar only are: A. Volume and area, B. Moment and momentum, C. Length and displacement, D. Impulse and time. So the pair, so what's scalar? Scalar is the one that has only magnitude but no direction. Only magnitude but no direction. So we also have vector, and vector has both magnitude and direction, while scalar have only magnitude but no direction. So volume has only scalar. I'll be representing it as S, while area has only scalar. It has only magnitude but no direction. While moment has vector, it has both magnitude and direction, and momentum has vector. Momentum has both magnitude and direction also. For length, length has only scalar. Length has only magnitude but no direction. While displacement is vector quantity, displacement has both magnitude and direction. And for impulse is a vector quantity. Impulse has both magnitude and direction, while time is scalar quantity. Time has only magnitude but no direction. So we have to check for the pair of physical quantity that are scalar only. That are what? That are scalar only. So let's start from option D. Both impulse and time are not scalar. Impulse is vector, while time is scalar. So option D is wrong. Option C. Length and displacement. Length is scalar while displacement is vector. So option C is wrong. We are looking for the one that has both scalar. For option B, moment and momentum is both, the two are vector quantities. So it's also wrong. The correct answer is option A. Volume and area are both scalar only. Volume and area is the correct answer. Question 28. The instrument used to view stars is the dash. A. Prism, binoculars. B. Telescope. C. Film projector. D. Microscope. I explained earlier that the instrument for viewing star is telescope. Telescope is the one used for viewing star. With the help of convex lens, it is used for viewing star. So telescope is the correct answer. And for microscope, we all know microscope. Microscope is the instrument used for viewing tiny images that naked eye can barely see, or that is too small for naked eye to see. Microscope is used for viewing that kind of image. So guys, let's move to the next one. And if you are watching and you haven't subscribed, please subscribe now as we move to the next one. Question 29. When the human eye loses its power of accommodation, the defect is known as A. Astigmatism, B. Long-sightedness, C. Short-sightedness, D. Presbyopia. So guys, let's start from astigmatism. So astigmatism is a defect of the eye in which the individual or the person will not be able to see clearly. The vision will be very blurry, and it is corrected by cylindrical lens. It is corrected by cylindrical lenses. And for long-sightedness, another name for long-sightedness is hypermetropia. And it is being corrected by convex lens. So another name for short-sightedness is myopia. Myopia. And for presbyopia is a defect of the eye, and it occurs when the eye is aging. When the eye is aging, when an individual is getting to a certain age, the eye will begin to age, and this is when the presbyopia occurs. And this presbyopia is the ability of the eye to lose focus on the distant object and the near object. So the question says, when the human eye loses the power of accommodation, what is the power of accommodation? The power of accommodation is to be able to see distant objects, when I say distant object, I mean far objects. And when the eye is able to see near objects, when the eye is able to see both near and far, that is the power of accommodation. And when the eye loses the power of accommodation, the terminology is presbyopia. Presbyopia is when the human eye loses the power of accommodation, when the eye begins to age. That is when the ciliary muscle begin to weaken. So let's move to the next one. Question 30. The heat required to raise a mass of a substance through 1 K is known as, this 1 K means 1 Kelvin. Through 1 Kelvin is known as A, specific heat capacity, B, specific latent heat of vapor, C, capacity latent heat of fusion, D, heat capacity. So specific heat capacity is the heat required to raise a mass of a substance through 1 K. That is the specific heat capacity. Let's move to the next question. Which of the following is a secondary color? A, blue, B, orange, C, red, D, green. So let's start from green. Green is a primary color. Green is a primary color. And for red is a primary color. Red is a primary color, while orange is a secondary color, and blue is also a primary color. So you can be able to differentiate the 4 colors, one that is primary and the one that is secondary. So the only secondary in the option is orange. Orange. Question 32. Which of the following is used for the correction of short-sightedness? A, concave lens, B, concave mirror, C, convex mirror, D, convex lens. So for the correction of short-sightedness, the concave lens is the correction of short-sightedness. While for convex lens is used for the correction of long-sightedness, as I mentioned earlier here. So guys, if you haven't subscribed, or you are a new viewer just watching this video and you haven't subscribed, please subscribe now, and make sure you drop a comment in the comment section. If you have any question to ask pertaining this video or anything to ask me, just feel free and drop your question in the comment section. I'll make sure I reply you. Just drop it, I'll make sure I reply you. And make sure you share this video. Share it to your WhatsApp status, share it to your Facebook, share it to anywhere you can share it to, and make sure you share it to your friend, especially your friends that are in need of this video. Don't be selfish. This video is really helping you, which I know. Make sure you share this video to your friends and even especially your classmates also that are in need of this video. So guys, let's move to the next one. Question 33. A train with an initial velocity of 20 meters per second is subjected to a uniform deceleration of 2 meters per second square. The time required to bring the train to a complete halt is, so let's solve. A, 40 seconds, B, 10 seconds, C, 20 seconds, D, 5 seconds. We need to solve before we can know our answer. So the formula for acceleration is V minus U over T. As I said earlier, we have to minus our final velocity from our initial velocity divided by our time to get our acceleration. Okay, let's solve. Our acceleration is 2 meter per second square equals, acceleration is also equals to deceleration. It's just that acceleration is plus while deceleration is minus. So our deceleration is 2 meter per second square. Our velocity is, our initial velocity is 0 and our final velocity is 20. So our initial velocity is 0 divided by our time. We are looking for our time. They say the time required to bring the train to a complete halt is, what is the meaning of complete halt? Complete halt is means complete stop. When the train is going to, when the time to required to bring the train to a complete stop. So what are we going to do? We are going to interchange. We are going to bring our acceleration here and make our time the subject of the formula, or we interchange. How do we interchange? By making t, by bringing t and bringing acceleration here. So t equals 20 minus 0 over 2. So our t equals 20 minus 0 is 20 divided by 2. So 2 divided by 20 is 10 seconds. 10 seconds. And another method we can use is by cross multiplying. If you cross multiply, we will now be left with 2t equals 20. 2t equals 20. So we now divide both sides by 2. 2 cancel 2. We are now left with 10. 10 seconds. Using two formula, getting the same answer is what Learn with Israel do. We do this for fun. So if you also want to do this for fun, stay tuned and let's do this together. And if you check the option B is the correct answer, which is 10 seconds. So let's move to question 34. The wavelength of a wave traveling with a velocity of 420 meters per second is 42 meters. What is the period? What is the period? So this question is under wave. It's under wave. And how do we solve it? Our period, the formula period is represented as t, and the formula for period is 1 over f. What's the meaning of this f? This f stands for frequency, and the formula for frequency equals v over lambda. V over lambda. This lambda represents what? It represents the wavelength, while this v represents the wave speed, and this wave speed is also the velocity. Don't misinterpret this. This v represents the wave speed and it also represents the velocity. So let's solve. We are looking for our period, but we don't know our frequency. We don't know our frequency. So how do? We have to first get our frequency by using this formula. So how do we do that? Our v, which our velocity is 420 meters per second, divided by our wavelength, which is also known as our wave speed, which is 42 meters. 42 meters. So guys, let's divide it. 42 divided by 420 will give us 10 meters per second. You can check your calculator to convert that, but it is wrong to leave it at 10 meters per second. Do you know why? Do you know why? Because frequency is measured in hertz. It's measured in hertz. Hertz is written as Hz. Hz. I want you guys to note all this unit. It is very, very important. So guys, let's now solve for period, since we have our frequency now. So our period equals 1 all over f, which is the frequency. So our frequency is represented as 10. So our period equals 1 divided by 10 will give us 0.1 what? Seconds, because time is measured in seconds. And if we check our option, we can find that in option B, 0.1 seconds is the correct answer. So guys, let's move to the next one. Question 35. Which of the following is not a vector quantity? A. Altitude. B. Acceleration. C. Displacement. D. Weight. So let's start from weight. Weight is a vector quantity. It has both magnitude and direction. And for displacement, as I mentioned earlier, displacement also is a vector quantity. It has both magnitude and direction. And for acceleration is also a vector quantity. And for altitude, altitude is a scalar quantity. It has only what? Only magnitude and no direction. Question 36. The ability of the human eye to focus objects on the retina is referred to as the power of what? A. Interference. B. Diffraction. C. Accommodation. D. Superposition. I remembered in this video earlier, I mentioned when treating question earlier, I talked about the power of accommodation to accommodate what is near and what is distant. And you can see that is what we are treating here. So the ability of human eye to focus objects on the retina is referred to as the power of what? The power of accommodation. Question 37. A manometer is an instrument used for measuring A. Relative density of liquid. B. Pressure in liquid and gases. C. Humidity. D. Atmospheric pressure. So guys, a manometer is an instrument used for measuring pressure in liquid and pressure in gases. So let's check. Yeah, it's in option B, pressure in liquid and gases. A manometer is an instrument used for measuring pressure in liquid and gases. And for humidity, relative hygrometer is used for measuring humidity. So guys, let's check question 38. Which of the following obeys Ohm's law? A. Electrolytes. B. Metals. C. Diode. D. Glass. So out of the option, it is only metals that obey Ohm's law. The current passing through a metal conductor, it is directly proportional to the potential difference, also known as voltage. Also known as what? Voltage. And the formula for Ohm's law is IV. And this is the current which is passing through the metal and directly proportional to the V, which is the voltage, which is also known as the potential difference. I hope you understand that now. It is the metals that obeys Ohm's law. So guys, let's continue. Question 39. Which of the following is the dimension of pressure? A. ml raised to the power minus 1 t raised to the power minus 2. B. ml t raised to the power minus 2. C. ml raised to the power 2 t raised to the power minus 3. D. ml raised to the power minus 3. So guys, before we do anything, we need to know the formula for pressure. Guys, what's the formula for pressure? I hope you are solving this question as I am also solving. So keep solving and make sure you drop your answer in the comment section for this particular question. JAMB always repeat this question every year. Don't treat this question lightly. Take it seriously. Take it what? Take it seriously. So the formula for pressure is force all over area. Force all over area. And the formula for force is mass times acceleration. Mass times acceleration. It is mass times acceleration, and the mass times acceleration, mass is represented as m, multiplied by our acceleration is represented as lt. Lt minus 2. Lt minus 2. So our acceleration is change in velocity over change in time. So that's how we get this Lt minus 2. So guys, let's multiply. So m multiplied by Lt raised to the power minus 2, that's mlt minus 2. So that's our force. Our force is mlt minus 2. So let's bring it back here. So our area is represented as length times length. So our force is mlt minus 2. We have one invisible one here, and we also have one invisible one here. You all know that. So our area is length times length. So that will be L2. Let's represent it as L squared. So our pressure equals ML1 minus, let's take our L2 up here. So let's represent it as 2. Let's take our L up there. So we have 2. C minus 2. So our pressure equals ml. 1 minus 2 will give us minus 1 T minus 2. So the correct answer is ml minus 1 T minus 2. And if we check the option, we can find it in option A, ml minus 1 T minus 2. If you need more understanding on this particular question, go and check the video I made on units and measurement under my YouTube channel. Check the video I made on units and measurement. You will have a better understanding on the dimension. So let's move to the last question under episode 2. A radioactive isotope has a decay constant of 10 raised to the power minus 6 seconds per second. Calculate the half-life. Calculate the half-life. So the formula for half-life is T half equals 0.693 over decay constant. So the decay constant is represented like this. Our T half, which is also the half-life, equals 0.693. So what's our decay constant in the option? In the question, our decay constant is 10 raised to the power minus 6. So let's input it here. 10 raised to the power minus 6. So our half-life equals what? It equals 0.693 all over 10 raised to the power minus 6. So let's change this to standard form. We now have T half, which is half-life, equals 6.93 multiplied by 10 raised to the power 1. I hope you understand this simple math. 6.93 raised to the power 10 multiplied by 10 raised to the power 1 over 10 raised to the power minus 6. So guys, let's bring it here. We now have T equals 6.93 multiplied by 10 raised to the power minus 10 raised to the power 1 over 10 raised to the power minus 6. So let's bring it here. Let's bring minus 6 here. So we are now left with T half equals 6.93 multiplied by 10 raised to the power 1 minus 6. So T half, which is half-life, equals 6.93 multiplied by 10 raised to the power minus 5. 1 minus 6 is 5. There's no need of taking 10 up there since we already have our 10 here represented here. So we just take only minus 6 and minus it from the 1 here and get minus 5. And if we check our option, you can find it in what? Wait. Oh, there is a mistake. What's that mistake? Since we can't find this in the option, what's the mistake? Check it well. We can find the mistake here. What's the mistake? Who can guess the mistake right? The mistake is that when we take minus 6 here, it returns to what? It returns to plus. That's the mistake. So let's change this minus to plus. 1 plus 6 is 7. 1 plus, when minus 6 go there, it turns to plus. So 1 plus 6 is 7. So we are now left with 6.93 times 10 raised to the power 7. Note this, guys. If you get your answer and you solve it correctly and get your answer, and you are realizing that the answer is not in the option, calm down and go through it. You know, when I go through the solvings, I realize that there is a little mistake here. That's why the answer is not correct, and I corrected it. So instead of cleaning it up and starting all over again, just check well and correct your simple mistake that you made. So, and if we check the option, we can find it in option B, 6.93 times 10 raised to the power 7 seconds. So guys, we've come to the end of this video. If you find this video helpful, please like, share to your friend and classmates and your WhatsApp status, and share it to anywhere you can share it to. Share it to everyone that you know that is in need of this kind of video. Don't be selfish. And so guys, we've treated episode 2. And if you haven't watched episode 1, make sure you watch that video. There is a lot for you there today. And in the next video, we will be treating episode 3, which will be from question 41 to 60. See you guys in the next one.